All right, so starting with a 45, 45, 90 special right triangle, what do we know the type of triangle it is if we have two equal angles? Well, if we have two equal sides, we have two equal sides. Two equal angles means two equal sides. Two equal sides means two equal angles. So since these two angles here are the same, then these two legs are also the same. So the main thing with special right triangles is making sure you're labeling the sides correctly so that you can follow the pattern, okay? So your legs will be labeled with an X. Your hypotenuse will be labeled with X square root of 2. So both of my legs will have a length of X, whatever that may be. So if my legs are both 5, then my hypotenuse would be 5 square root 2 because you just replace the X with what it is equal to. So what we're going to do is label the triangles with the appropriate labels. Do not get confused with their X and their Y that are on here, okay? Their X and their Y is just so you know how to fill in these two spaces down here. But you're going to put your labels, okay? So first off, since we have a 45, 45, 90, then I'm going to call both of my legs X. I'm going to call my hypotenuse X square root of 2. Make sure you are labeling. So now, the next thing you're going to want to do is to circle the label of the given side. So they gave me this, so I'm going to circle that. So what that means is X is equal to 8. Because they told me that side is 8, and that side is labeled X, correct? Therefore, it's X equals 8, which means this side over here is also 8. So I'm going to come down here. Since that side is their X, then I'm going to fill in their blank X equals 8. Okay? Now, the next thing I know is that if X is 8, then X square root of 2 is going to be 8 square root of 2, because all I'm going to do is replace the X with what it is actually equal to. So that means my hypotenuse has a length of 8 square root of 2. And so I will fill that in for their Y value because that is how they labeled it. So their X and their Y are irrelevant when you're solving. It's just so you know where to put the answer choices, okay? All right, I'm going to zoom in on this one a little bit. All right, so we have a 45, 45, 90, so I'm just going to worry about my labels. So the legs are X, the hypotenuse is X square root of 2. This is the pattern, okay? Circle the information that is given. They gave me that side is 25. Therefore, I know that X is 25. So therefore, this side is also 25. Which means if X is 25, then X square root of 2 is 25 square root of 2. You're going to replace the X with what X is equal to. And that is how you do special right triangles. All right, on number 3, just to keep it simple, I want you to change this 19. I want you to change it to a 20. I want you to change it to a 20. Okay, because I want to be able to show you how this works without fractions being involved. So first thing I'm going to do is label my legs. And I'm going to label my hypotenuse. The next thing I'm going to do is circle the information that's given. So now I know that X square root of 2 is equal to 20. Well, this isn't the same as the first two where we already knew what X was. So what I want you to think about is if this said 2X equals 20, since that means 2 times X, we would divide to get X, correct? So X equals 10. But it's not 2, it's the square root of 2 that I'm multiplying by. So since I'm multiplying by the square root of 2, then I need to divide by the square root of 2 because I'm trying to find out what X is. They didn't give me X this time. So if you recall from when we simplified radicals, you cannot have a radical in the denominator. So I'm going to rationalize by multiplying by the square root of 2. So 20 times the square root of 2 is 20 square root of 2. The square root of 2 times the square root of 2 is 2. Now I can simplify the 20 over 2 because 20 divided by 2 is really 10. But the square root of 2 in the numerator still exists. So that means my legs are 10 square root of 2. So now I can just go down here and fill out what the legs are. Okay? So, do you have to do this every single time? Not if you recognize the pattern. Okay? If you notice that when we divided by the square root of 2 here, and then multiplied by the square root of 2, the whole point is we're trying to get rid of the square root in the denominator. Okay? So if you think about it, we started with 20, we ended with 10 square root 2. So technically what we did is we divided by 2 and multiplied by the square root of 2. So if you take the number, when you have this scenario, I'm going to slide over here. So if I have this scenario where maybe it's 18 square root of 2, or not 18 square root of 2, let me just put 18. So 18 is equal to x square root of 2. Well, since 18 is equal to x square root of 2, then I have to divide by the square root of 2. If you notice the pattern, when you divide by the square root of 2, you're dividing by 2. So what is 18 divided by 2? 9. But then you have to multiply by the square root of 2. So when you have this scenario where a number is equal to x square root 2, all you're doing is dividing by 2, multiplying by the square root to get your answer, because that is exactly what we did. We multiplied by that, we divided by that. Okay? And you will do that frequently. All right, the next one, these are 30, 60, 90. So these are scaling right triangles, because if I have 3 different angles, then I have 3 different sides. So you're no longer going to label x square root of 2. Now the labels are completely different. So find your shortest leg. Where's the shortest leg located? Across from the smallest angle. Okay, remember the triangle inequalities from chapter 5. So your smallest side will always be opposite the smallest angle. So that is going to be x. Okay. Now, the next thing is I'm going to go straight to the hypotenuse. So my hypotenuse is always double whatever that shortest leg is. So if my shortest leg is 5, my hypotenuse is 10. If my shortest leg is 2, my hypotenuse is 4. It's always double. So this is always 2x. Now the longer leg, the side across from 60, this is x square root 3. And this is the pattern that you will follow when you are doing 30, 60, 90s. So when you start the assignment, they're going to be mixed up. So you have to pay attention to the angles because you can't do the same rule on every single triangle. So first thing I'm going to do is label this first one. So on number 4, I'm going to label the shortest side. I know since this angle is 60, then I know this angle up here is 30 because they have to add up to 90. So I'm going to go across from 30, and this is going to be x. My hypotenuse will be 2x, which means the long leg is x square root of 3. I'm going to do the same exact thing I did. I'm going to circle what they gave me. If x is 5, what is 2x? 10, because if 1x is 5, then 2 5s is 10, which means x square root of 3 is 5 square root of 3, because again, you're replacing x with what it is equal to. So now I can go down here and I see that their x is the x square root of 3, so 5 square root of 3, and their y is the 2x, which is 10. All right. Same thing here on this problem. I'm going to go to the smallest angle and I'm going to go straight across. So that's my x. The hypotenuse is 2x. And then the leftover side is x square root of 3. I'm going to circle what I know. So if x is 14, then 2x is 28, which means x square root of 3 is 14 square root of 3. Again, you are replacing x with what x is equal to. So y is the x square root of 3, and x is the 2x, so that I can fill in the blanks. Now, are they always going to give you the x side? No, of course not, because you are supposed to be able to go forward and backward. So I'm going to label all my sides. So across from 30 is x, across from the hypotenuse is 2x, and the other side is x square root of 3. I always label the short leg and the hypotenuse because those are the normal ones. They're half of each other or double, depending on which direction you're going. The other one just gets the weird label. Circle what you know. Well, now I know that 2x is 32. So if 2x is 32, then what is 1x? 16. So what is x square root of 3? 16 square root of 3. So now I know that this side is 16 square root of 3, and this side is 16. And that is pretty much the pattern, okay? So let's look at number 7. So obviously I could give you any of the 3 sides, and you have to be able to go forward and backward. So starting with the smallest side, if this angle is 60, then I know this angle is 30. So this is x. Across from the 90 is 2x, and the other side is x squared root of 3. Circling what I know. 2x is 46, so x is 23. So x square root of 3 is 23 square root of 3. So their x is the x square root of 3. Their y is our x. Remember, their labels have nothing to do with solving. It's just to fill in the blanks. Now, on number 8, I want you to turn this 20 into a 21, just so I can make it simple for explanation purposes. All right, same thing. Across from the 30 is our x, across from the 90 is our 2x, and of course the other side is x squared root of 3. So just like when x square root of 2 was equal to 20, x square root of 3 will now be equal to 21. So x square root of 3 is equal to 21. Well, when I looked up here when I did this problem, if really all I was doing was dividing by 2 and multiplying by the square root of 2, what do you think is going to happen when there's a 3? Now you'll divide by 3 and put the square root of 3. So that means x is 21 divided by 3 is 7 square root of 3, which means 2x is 14 square root of 3 because you're multiplying 2 times 7. So our x is 2x, so that's 14 square root of 3. Y is our x, which is 7 square root of 3. Had we left it as 20, then it would have been 20 over 3 square root of 3. And then you would have had to double that. But I wanted it to be as simple as possible so that you can just see the pattern. All right, what about across from 30 is x, across from 90 is 2x, and then this side is x square root 3. Circle what's given. So if x square root of 3 is equal to 9 square root of 3, well, this time if I divide by the square root of 3, don't the square roots of 3 just cancel out? So x is 9. If the x square roots of 3 cancel out, then x is just 9, which means 2x is 18. So that means this side is 9 and this side is 18. Questions? All right. So here on the back, now it is all mixed up. So you have to make sure you are labeling with the right labels. So identify what kind of triangle it is. 45 degrees means the other one is 45 degrees. So this is going to be x, x, x square root of 2. Circle what we know. Well, if x square root of 2 is equal to 28, then x is 28 divided by 2 is 14, multiplied by the square root of 2. So that means both of my legs are the same thing. Okay, number 11. This time we have a 30, 60, 90. So I'm going to come up here, I'm going to do 30. So across from 30 is x, across from 90 is 2x. The other side is x square root of 3. They gave me 2x. 2x equals 16, so x is 8. So x square root of 3 is 8 square root of 3. So their x is my 8 square root of 3. Their y is my x. So as long as you're following the pattern for the labels, you can do this pretty much with minimal work. Very minimal. Okay, we have another 45, 45, 90. So we've got x, x, x square root of 2. Well, if x is 4, then this side is also 4, which means this side is 4 square root of 2. Because you're replacing x with what x is equal to. The square root of 2 doesn't go away unless you divide by it. So I'm just going to go down to the 15, just kind of work myself backwards. Have a 45, 45, 90, x, x, x square root of 2. Well, if x square root of 2 is equal to 9 square root of 2, what is x? Anybody? 9. So that means both of these sides are 9. As long as there is a square root of 2 on both sides, they will both cancel out. Okay, number 14, I have a 30, 60, 90. Across from 30 is x, across from 90 is 2x. The other side is x square root of 3. So if x square root of 3 is equal to 15 square root of 3, what is x? X is 15. Remember, the square roots of 3 are going to match up, so they're going to cancel out. So if x is 15, then 2x is 30. So this side is 30, and this side is 15. All right. X, 2x, x square root of 3. It is the same thing repetitively. So x is 11. If x is 11, 2x is 22. So x square root of 3 is 11 square root of 3. Remember, you're replacing x. So this is 22. And this side is 11 square root of 3. Everything revolves around x. Whether you're the short leg or the isosceles. All right, here we go. Number 16. Across from the 30 is x. Across from the 90 is 2x. So this is x square root of 3. X square root of 3 is equal to 6. So this is where I have to do the rule. I can't just cancel out the square root of 3 because it's not existing visibly. So that means I'm going to divide by 3. So 6 divided by 3 is 2, and then bring the square root of 3 over. Divide by 3, multiply by the square root of 3. So that means your 2x is 4 square root of 3. Because remember the rules, you cannot multiply what's outside the radical with what is inside the radical. So this is 4 square root of 3. This side is 2 square root of 3. All right, now we have a square root of 10. We've only been doing square roots of 2's and square roots of 3's. So how do you do this one? The same exact way. Follow the rules. All right. So if this side is x, this side is x, this is x square root of 2. I'm going to circle what's given. Okay? So we got x square root of 2 is equal to the square root of 10. Well, now I can't divide by 2 because there's not a whole number to divide by 2, is there? So think about what's happening here. If I divide by the square root of 2, I get that x is. Well, what is the square root of 10 divided by the square root of 2? Are they both inside the radical?
Yeah.
Then what's 10 divided by 2? So it's the square root of 5. Okay, as long as they're both inside the radical, then you can put them together. But you can't do what's in with what's out. So both of my legs, because they are both equal, are both going to be the square root of 5, because it is a 45, 45, 90. All right. Last one, and then I am going to do the double triangles. So across from the 30 is our x, across from the 90 is our 2x, and then the other one is x square root 3. Circle what I know. 2x equals 38. So if 2x is 38, then 1x is 19. So that means this side is 19, which means x square root of 3 is 19 square root of 3. All right, so now we have these double triangles, one of each in every picture. So you have to decide which triangle you're going to do first solely by using the only piece of information that's given. So for example, the way I'm going to do this is I'm going to color one of them pink and one of them blue, so that when I'm doing my labels, I know which label belongs to which triangle. So across from 30 is x, across from 90 is 2x, and this is x square root of 3. I'm not going to worry about the blue triangle because I don't know anything about it yet. Okay? I do know that for the pink triangle, x is 9. So if x is 9, then 2x is 18. So this side is 18, which means that the x square root of 3 is 9 square root 3. So this side becomes 9 square root 3. Now looking at the blue triangle, this is x, and now this is x square root of 2. So if I circle what's given now, I see that x square root of 2 is equal to 9 square root 3. So this one will require me to do the work. Gonna have to rationalize. And I get that the numerator now is 9 square root of 6 over 2. So both of the legs are 9 square root of 6 over 2. Leave it as a fraction. It's usually not normal to have a decimal in front of a square root. So now if we go over here This is 9 square root 6 over 2. My y is also 9 square root of 6 over 2. And my z is 18. Questions? Yes, ma'am. Well, I can multiply 3 and 2 because they're both under the radical. As long as they're both under the radical, you can multiply them together. I can't multiply the 9 times the 3 times the 2 because the 9 is not underneath the radical. So it's like multiplying 9 times x. It's just going to be 9x. But if I had 9x times x, I could multiply the two x's. Does that make sense? So 9 times 3 is 6. The 9 is just out here without anybody to hang out with. But here, the square root of 2 times the square root of 2 is just 2. So now I've got 9 divided by 2, but I don't want it to be 4.5. I want it to stay a fraction. Because decimals do not go in front of square roots. All right. In number 20, I know something about the 45, 45, 90. So I will do that one first. So this is x, this is x, this is x square root of 2. Well, since x is 32, then that means this side is 32, and this side is 32 square root 2. Now if I label this triangle, I get this is x. Now this is 2x. Here, I will do this actually. 2x, and this side is x square root of 3. Circle what I know. Now 2x is 32, so x is 16, which means this side is 16, which means x square root of 3 is now 16 square root of 3. So if I label it, I get that this is 32 square root of 2, y is 16 square root of 3, and z is just 16. All right, I'm going to do, I can't remember which one we did last period. I think it was 24. So let's look at 24, and then we'll see. So I'm going to do this triangle first. So this is x, this is 2x, and this is x square root of 3. X square root of 3 is equal to 18. There's not a square root of 3 to cancel out, so I got to do the trick. Divide by 3, put the square root of 3. Therefore, 2x is 12 square root of 3. So this side is 12 square root 3, which makes this side 6 square root of 3. Now this one gets a whole new label, x square root 2. So anytime you have a square root of 2 equal to a square root of 3, you're going to have to do the actual math involved. So x square root of 2 is equal to 12 square root of 3. So if I divide by the square root of 2, I have to rationalize. So I get x is equal to 12 square root of 6 over 2, and then these two can simplify, so I get 6 square root 6. So now I know this is 6 square root 6, and this is 6 square root 6. So fill it in. Their x, we have 6 square root of 6. Their y, 6 square root of 6. Their z, 6 square root 3.